Okay, welcome back. We are in 6.7, which is on solving logarithmic equations. The very first thing in the book is a guideline for how to get through these problems. So let's take a look at what it says. The first step, you're going to want to isolate the logarithmic expression. So if you have, say, log of x plus 2 in there somewhere, you want that on one side and everything that's not a log on the other side. And then once you have that written as a log, just an isolated log, you're going to rewrite that as an exponential. Right? Put it in an exponential form. And then if you can, you'll go through steps 3 and 4. So if you can rewrite the exponentials on both sides as the same base to some power, you'll do that, set the exponents equal to each other, and then solve. If you can't do that, then you'll simplify the exponential form and then solve it that way. So let's see this in action with a couple of examples. Let's have perhaps log base 3 of 81 equals x. Right? The log is already isolated here. It's all by itself. It's already just a log on one side and everything that's not part of the log on the right-hand side. So I'll rewrite this as an exponential. So I'll write this as 3 to the x equals 81. Now I can complete steps 3 and 4 because 81 is 3 to the 4th. Right? So I'll write this as 3 to the x equals 3 to the 4th. And because I have the same base to one power as it is to another power, step 4 is to set those exponents equal to each other. Simplify if necessary. It's not necessary here. I'm done. I've solved it. And that's that. Alright, let's look at this one. I have the log base 8 of 16 equals x. So again, I'm going to rewrite this as an exponential because the logarithm is already isolated. It's the log on the left-hand side. Everything that's not part of the log is on the right. So this is 8 to the x equals 16. Now 16 is not a power of 8, but I can still go through steps 3 and 4, because 8 and 16 both happen to be powers of 2. So 8 happens to be 2 to the 3rd, so if I replace the 8 to the x with 2 to the 3rd to the x, and then 16 happens to be 2 to the 4th, what I can do with these exponents on the left here is 2 to the 3rd to the x becomes 2 to the 3x. You multiply those powers. And now I have 2 to one power is equal to 2 to another power, therefore those powers must be the same. And so 3x equals 4, and then I solve. I set my exponents equal to each other, and then I solve, and I do that simply by dividing by 3, and so I get x is equal to 4/3. Good. Okay, let's take let's take 4 plus the log base 4 of 32 equals x. Now we have to take care of that first step, and that is to isolate the log. The log has this 4 that's added to the left of it. I need to get that out of there so that I can rewrite this as an exponential. So I'll simply subtract 4 from both sides. That eliminates the 4 and leaves me isolated with a log. Base 4 of 32 is equal to x minus 4 on the right. Okay. Now I can rewrite this as 4 raised to the x minus 4 power is equal to 32. Now 32 isn't a power of 4. 4 times 4 is 16, times the next 4 gets you to 64, so you skip over this 32. But again, both of these are powers of 2, so I can rewrite them as 2 to the second and 2 to the, what is that, 5? Yeah. So I'll write this as 2 squared to the x minus 4 power. Okay, that shadow is a nightmare, isn't it? Equals, and then 32 is 2 to the 5th. Now, I just have to be careful because this is 2 to the 2 that gets multiplied by x minus 4, but x minus 4 is a binomial. It's still all my power. So this 2 gets distributed through there, so be careful with this. This ends up as being 2 to the 2x minus 8 power as that 2 gets distributed through. And that's equal to 2 to the 5th. Now I have the same base on each side, so I can take 2x minus 8 must be equal to 5. And then I solve. Add 8 to both sides, that gives me 2x equals 13. Divide each side by 2, and I have my answer, x is 13 halves. Let's look at this one here. Let's say I have the log base 3 of x. Equals 3. Again, that log is already isolated, so I'm going to rewrite this as 3 to the 3 is equal to x. And now I don't have to do steps 3 and 4 because I can't write the right hand side as 3 to some power. I don't know how to do that, but I do know that 3 to the 3 is just 27. So by simplifying it now, I'm done. X is 27, that's all there is to that one. Let's say we have the log base. Let's do something different than 3. Let's do the log base 7 of x minus 4 equals 2. Okay. Well, the log is isolated. It's the log of an expression, but the logarithmic expression itself is isolated, and so I can rewrite that as 7 to the 2 equals x minus 4. And again, I can't write this right-hand side as 7 to some power, so I'll just evaluate the exponent here. 7 squared is 49. And if I add 4 to both sides, I'm done. So x equals 49 plus 4. And we have x equals 53. Alright, let's look at one last one here. Let's look at 3 plus the log. I'm going to do this example from the bottom of the book. Log base 3 of 2x plus 5 equals 6. So again, first I need to isolate that logarithmic expression. So I'm going to subtract 3 from both sides. That gives me the log base 3 of 2x plus 5 equals 3. Rewrite this as an exponential. 3 to the 3, which is 27. Oh, sorry. I'll write it. 3 to the 3 equals 2x plus 5. So again, all I have to do is evaluate this 3 to the 3, which is 27. Subtract 5 from both sides and just solve for x here. Dividing each side by 2, I find x equals 11. Now, I know I said that was going to be the last one. I lied. Let's do a couple more just to see some other interesting things that might pop up. Sometimes you might end up with a log that equals another log. So if I have something like, say, the log base 2 of 3x minus 5 is equal to the log base 2 of 5x plus 1. Right? In fact, let's do this. That one's not going to work. Let's do... Oh, that'll work, I think. Okay. But if I have the log base 2 of one thing equals the log base 2 of another thing, then these things in the middle here have to be the same, right? Due to the nature of the log, I can't take the log of one thing and have it equal the log of something different. If it's the same, if the logs are the same, then the insides are the same. So I can eliminate this log altogether and just then say that 3x plus 5 has to be equal to 5x minus 7, sorry. And then I just solve this. I'll subtract 3x from both sides to put them to the right. Since they're going right, I'm going to add 7 to both sides. That gives me 12 equals 2x, and therefore divide each side by 2 and I get x equals 6. Now, one thing that we haven't been doing, because we haven't had to, is that we should always check our answers. X equals 6, I need to be able to take 6 and plug it into 3x plus 5 and get a positive number out of there, because I can't take the log of a negative number. And I can't take, so I also need to plug it in here, so I can't take the log of a negative number, I can't take the log of 0, so I need to be able to plug it in here and get a positive number. But I think you'll see if you do that, and any of the ones that we've done previously, that that is the case. Thank you, and I will see you guys for the next one.